working this limiting reactant problem, there are just several steps you have to go through. First of all, when we see grams, we need to convert our grams of each of the reactants to moles. To do that, I'm just simply going to divide by the molar mass of each of them. So in the first one, I have 1.5 grams of zinc. So if I divide this by zinc's molar mass, which is 65.39, I see that I have 0.0229 moles of zinc. And then I'm going to do the same thing with AgNO3. So if you add up AgNO3's molar mass, it equals 169.87. So that if I then divide that out, I get 0.0275 moles of AgNO3. Well, the first question asked us to identify the limiting reactant. We cannot just look at the moles because it has to do with not only the moles, but the mole ratio that's occurring up in the reaction. So I can see from the reaction that for every 2 moles of Ag, I'm required to have 1 mole of zinc. So half as much zinc. So then if I take a look, so if I just show the calculations here, if I take a look, we can just kind of look at the zinc. So I know if I have 0.0229 moles of zinc, that I'll be required to have twice that amount if I'm AgNO3. So if I take a look at that, so my ratio of zinc to Ag, so if I'm looking at that, it's going to be a 2-to-1. So that's the moles of zinc. So if I were to work this out, when I work out this problem, I see that my requirement for my, if I do the math here real quick, so if I double this up, I get that I should have 0.0458 moles of silver nitrate. My problem is if I take a look at my what I have in my reactants in my cupboard, basically, I don't have enough. So I need 0.0458 to be able to consume all the zinc, but I only have 0.0275. So instantly I see that my silver nitrate is my limiting reactant. So the answer here would be the limiting reactant would be silver nitrate. So AgNO3 is a limiting reactant. So then it asks me how much excess reactant remains. And so what we're going to do is we can kind of work this a little backwards. And I'm going to move up and just create a BCA table to be able to answer the remaining questions. So we know then that before the reaction starts that I have 0.0275 moles of silver nitrate and 0.0229 moles of zinc, and I don't have any, I'm going to kind of put a little dividing line here, I don't have any product yet. So then what's going to be the change once the reaction takes place? Well, it's all about the limiting reactant. So I'm going to write down the limiting reactant under everybody on the change line. Because I know that that's what's going to be consumed up, some proportion of the 0.0275 moles of AgNO3. And so what proportion? Well, it's all based on this 2 up here around the AgNO3. So I'm going to divide all the coefficients by 2, and that's going to tell me the proportion. So then when I work these out, I know that this obviously is just 0. Good morning. So when we work these out, I'm going to go ahead and do the math. And so if I look at this half of 0.0275, that's going to equal 0.0138 moles. So again here and here, because it's a 1-to-1, a 2-to-2 is a 1-to-1, it's same value. So these are the numbers that I need to either be consumed on the reactant side or be made on the product side. So now if we work this out, our after line is if this right here, your limiting reactant, will always be 0. Then if I subtract, I don't have a whole lot of moles in excess left over. It's just 0.0091 moles of zinc will be left, but I do have some left. You know you made a mistake on your limiting reactant if what you use is more than what you actually have. So in this case, I have some left over, so that works. This side you add, so on the reactant side, you subtract, and on the product side, you add, because you are creating the product. So I'm going to add to 0, so 0.0138 moles and 0.0275 moles of silver. So those are kind of now my answers on the BCA table. So now it's really easy to see how many moles of excess reactant remain. 0.0138 moles of zinc will be left over. And then working down here, it says on the basis of this limiting reactant, determine the grams of silver. Well, real easy, I can see that I have 0.0275 moles of silver off the previous reaction. So then all I have to do now is multiply that by silver's molar mass, and the result then, so this is my grams per mole for my molar mass, the result then is 2.97 grams of silver. So now that is my, in theory, theoretical yield, because all this is math, it's on paper. But then the last question says, well, if in a lab situation we did all this, we added the 1.5 grams and the 4.67 grams of silver nitrate, but we only were able to get 2.5 grams of silver. So what was my theoretical and actual yield? Well, the 2.50 is my actual yield. If I divide that by, in theory, what I should get, tells me how good my lab process was. It's called percent yield. So I'm going to work that out so that I find out that this was a pretty good lab. It was an 84.2% yield. So again, the formula that we use is our actual yield divided by our theoretical yield times 100. And that is limiting reactants.